Some of you guys were confused about what. Alright guys, find this page in your packet. We're just going to do one to kind of refresh your memory of what this looks like. So guys, looking at this, how long are your petals? 5. How many petals would you expect to have? 3. And could you figure out where those petals are?
Yes.
Okay, so let's do this by plotting points instead so that we can plot them in order. But we're still going to graph the entire thing. So you know what it should look like, right? So you guys have in your mind what this should look like. So let's think about plugging in some thetas. If I start with a theta of 0, maybe I need a theta of 0. I don't know why this is being so slow. What are you going to get for R? If I plug in 0 for theta, what do I get for R? 5. Okay, as far as picking another theta to plug in, be aware that there's a 3 here. So plug in things that are going to be fairly easy to plug in, which it works out pretty simply in this one. Could I plug in pi over 6? Okay, so when I plug that in, that's 3 times pi over 6, which is really pi over 2. So what do I get here? 0 for R, right? You with me? Okay, are you still looking for this page? We're good now?
Well, I put through the entire thing. It was on the back. So.
No, I know. It's stapled together in a bag. Okay. All right. Pi over 4 I could do. I don't think I really want to do any of the over 4s. It's going to be kind of ugly. So let's jump to pi over 3. So 3 times pi over 3, that's really just pi, right? So what do I get for R? Negative 5. Should I do pi over 2? I could, but that's not going to be too ugly, because that's going to give me 3 pi over 2, right? What do I get for that then? 0. Right? Just pretending that's... Alright, and then I'm just going to keep working my way around the circle. So next would be 2 pi over 3. So what do I get? Okay, so what would I get for R then? 5. Bless you.
Oh, bless you.
I was sorry. I was thinking.
Are you recording?
I am recording.
Oh, I can hear my voice. Okay.
Well, okay. Alright, so let's plug in 5 pi over 6.
Whoa.
What do I get? I may have to also record, right?
Really badly right now.
Alright, 5 pi over 6, what are you going to get? That's like pi over 2, right? 0. Any of the over 2's end up being 0, right? Let's plug in pi.
Oh my gosh, man.
What do I get when I plug in pi? So again, guys, you gotta know those trig values quickly. Negative 5. Thank you. Let's do... I could do 7 pi over 6. Okay. What else do you want to do? Do we have enough? Let's do a couple more. What do you want to do? 4 pi over 3? Sure. What do I get? Positive 5, right? Let's go ahead. Let's do 3 pi over 2, and then we'll stop. So on your quiz, there will be some that I say only graph from 0 to pi over 2. So you won't have this many points to plug in, but you have to understand the idea of how this works. So, which I think we'll get into the idea. What do I get with 3 pi over 2? What? 0, yes, good. Okay, so let's think about what these points are. Is everybody okay with the table, like where these things are coming from?
Yeah.
Okay, so I'm going to plot 5, 0. Remember, you go your R first and then travel that angle. So 5, 0 is out here. Then 0, pi over 6, well, that's right in the middle. What is that point right in the middle called? So the pole is when R equals 0. Okay, you got to know that. Yes, that may come up on that weird multiple choice today.
Say that again?
It's going to access my 3
The pole happens when R equals 0, right? Okay, just saying.
Oh, is that the answer? Thank you.
No, that is not. But if you don't understand that, it's hard to find the answer. Okay, so the next one, -5 and then pi over 3. -5 pi over 3 is down here, right? So let's think about what we've drawn so far. I've drawn that part of a petal and that part of a petal, right?
Wait, how do you know that it's not on the other side?
So think about you're at +5 going to 0, so it's going to be 5, 4, 3, 2, 1. You know what I mean? Like that's the distance that you're approaching. Your angles are going in a positive direction, so you're here. Okay. All right. The next one would have been 0 pi over 2. So that means I'm going back to the pole. So I'm going back to there. Okay. Then I've got +5, 2 pi over 3. That's this guy, right? See him up there?
Yeah.
So I'm going there. And then 5 pi over 6 takes me back to 0. So back to the pole. A little squiggly there. All right, then we've got -5, and we go all the way to pi. So that's taking me back to that first point. So that's filling in that part of it. So what is going to happen with all of these values between pi and 2 pi, like after pi? It just repeats the pattern. So guys, that's why when it was a 3, a 5, a 7 theta, whenever this is odd, you just get that number of petals because they repeat as you travel all the way around 2 pi. If it's an even number, like say this was a 4, you would actually get 8 different petals as you go around. Okay? Does that make sense?
Yeah.
Okay. Yes.
So we have 2 petals.
No. Lemniscates only have 2, and that's something different. All right, how do we feel about that one? Okay. So let's try. Let's keep turning in your notes. We'll come back and possibly practice some of these. Find this. This is at the bottom. Let's do this one. All the way to here. Jumping. We may come back and practice more. All right, so R equals 4 cosine 3 theta, and we're only going from 0 to pi over 2. Okay, guys. All right, so I'm going to make a little table. So R theta. All right, do I need to go all the way to 2 pi this time? No. You know if you graph the whole thing, you have 3 petals. Probably not going to have 3 petals. And let's think about it. The last one that had 3 petals, we saw all 3 petals by the time we got to pi, right? So pi over 2, how many petals do you think you're going to see? 1.5 probably, okay? So just to kind of mentally check, make sure you're on the right track. I know I need to plug in 0. I know I'm going to end up plugging in pi over 2. What do you think I'm going to plug in between those? It will be nice. Pi over 6, pi over 3. Good. So we only have 4 that we have to think about this time, okay? All right. So when my theta is 0, what do I get for r? 4. When my theta is pi over 6, what do I get for r? 0. A little slower with that one. When my theta is pi over 3. -4, good. And when it's pi over 2? 0. All right. Everybody with me on the table? Okay. Question? You sure?
Yeah.
Okay. So let's plot them in order and try to think about connecting them in order. So 4, 0, we know is out here, right? I want to make sure everybody's with me a dot at a time. Good with the first one, right?
Yeah, of course.
Okay. Then 0 pi over 6, so that's back at the pole. You don't connect them with just a straight line. What am I going to see with this? Yeah, like half a petal, right? And I'm going to see that guy. All right, then where am I going? -4 pi over 3, so that's down here, right?
Yeah.
Okay. Okay, and then I have to come back to the poles. So, did I get 1.5 petals? Yes.
Oh, right.
Stop. Weird, right? Okay. All right. You guys try the second one here. See how you do on that. Yes. What's up, Ricky? Give me 1 second here, okay? And again, you have in your head what this should look like if you graph the whole thing, right? So we are picking theta, so we're plugging them in. So new theta is 0. And it's 0.
Oh, it's not.
Okay.
Oh, you go to the other. Oh, but no, I went -4. That's not good. That's my bad.
1 times 5.
So wait.
So if you plot it, you've got 0. So 3 times pi over 6 is
So wait, it's like this.
and pick the ones that are nice, like don't
It's the opposite.
So here, you start with 0, pi over 6, pi over 3, pi over 2. That's all. So that's why it's only right, but you have to understand that.
Oh, no, wait, let's go like this. I don't know why. I'm not on
Oh, that's.
But
he said he wanted to
No, it should. I love it.
It's just grass, so there's no like burning.
What, that's what I like.
All right, guys, how's your grass look?
Yeah.
Yeah? All right, let's think about it. So R and theta. Did you again use 0, pi over 6, pi over 3, and pi over 2? Okay, and your R's this time were what? 0, 4, 0, negative 4? Okay, so we start at the pole this time. Then we come out here. So we do that, right? And then we go back to the pole. And then I go down here. That's it. Yeah? Not that bad, right?
I got a lot of them.
All right. So far, so good. Let's do this guy. Okay, so think about it, guys. If you were graphing the entire thing, how many petals would you expect to see? 8. We're doing half of that. We're going from 0 to pi. So how many petals do you think you're going to see? 4. Okay. Realize when you're doing like 4 petals, it could be, you might have 2 half petals going on somewhere. You know what I mean? They may not all be 4 complete petals, but so think about it. Plot your values. Do some math.
Why did you change it to 4?
I think this is a little trickier just because you have more. How are you doing with your thetas, guys? What are you picking?
I mean, if you want to leave out all the zeros.
Yeah, guys, if you end up making your table and you're like, oh, I missed all of the ones that go to the pole, do you know that this goes through the pole?
Yeah.
So that's okay. Like, it's fine for you to just use your brain and understand what's happening. I'm okay with that, right? Brain power here.
Yes. That's on the recording.
You called it. I think it's one of the best teachers.
It's like 2 pi. Oh, it's so nice. It feels so nice to get off. Feels so smooth. Perfect. You couldn't even tell.
Yeah. So what's 3 times pi over 6? Okay, and then the cosine of pi over 6.
Stop saying that. When you say pi over 6.
The cosine of pi over 2.
Cosine of 2 pi over 6. What if it's like
Zero. Okay. So 0 comes to what? Pi over. The original theta you plugged in, yeah.
If we find like the pi over 6, so we do 4 times pi over 6 will get this, and then cosine of 5, and then times -5. Yeah? And so I got
Which,
cosine.
how are you getting 0 out of that?
Oh, where?
Pi over 6? Because 4 times pi over 6 is like 2
2 pi over 6, 2 pi cosine of 2 pi over 6. So it's non-rational, but so it's negative 1/2.
Yeah, so how are you getting 0? And that's going to be kind of a pain to plot, so I'm probably not going to do that.
Oh, okay.
You know what I mean? Like, I'm going to use the ones that are the ends of the petals and know that I don't.
Primitive.
No, I know.
It's
I
like
tell
I
you
never
that.
get like
There's
that.
no break.
See, I know it. And I heard people say like, I've never seen something like that before. Because in a language class, they could test you on using.
Yeah, it's definitely different. How are we doing, guys?
You can't find any points to go through the origin. Kind of be like,
Oh shoot, I'm gonna run that.
wait, so there's some points in the list of 2 pi that would be
Yes.
I just put all the pi befores, the pi routines.
You're just gonna keep, you're gonna hope everyone understands your. Oh my god, I know. Wait, shoot, that means. Yeah, I was trying to
But I'm going to show you something with that one that makes it easier. Yes. Just to save yourself a little bit. All right, guys, let's look at this one. So we start over here. Was your first point over here at -5, 0? Yeah. Okay. I didn't plug in what's going to take you through the origin, but I know it's going through the pole. And then the next one I had is what? Like at pi over 4? Yeah. And then it comes back through, right? And then -5 pi over 2?
Yep.
Which is down here. Okay. And then 3 pi over 4, so I gotta get all the way to up there. So I'm going back through. End up. And then where do I end up? Over there, right?
Yeah, -5, 5.
Yeah. So, do you see what I mean? How you have like 2 half petals here?
Yep.
How do you do on that?
Better than I expected.
Okay, yeah.
Because like this is for you might want to use that. Just like that, because you know it's going to go back.
But I am probably gonna do
Mine is probably 237 points.
all right, guys, I'm jumping around a little. Try number 5 for me. And then we're going to do 6 together. And I'm going to show you something that makes it a little easier. What?
What about everybody else? You're not the only one in this group.
I don't know, Sean. I don't know what to tell you.
Take a class. Do you want to solve the problem You like a riddle? Yeah. Riddles are not my strong suit. It's so weird, actually. It's like really. It's funny. You get close. No, you didn't think you got close. We tried to do red herring. Red herrings are like crazy.
Excuse me. Thank you.
No way.
Those are what I picked. Good job, guys. Guys, the thetas I picked were 0, pi over 4, pi over 2, 3 pi over 4, and pi. And again, how many petals are you expecting to see? 4 if you graphed the whole thing. So 2. Around we're only going to pi. Around 2.
Could be one somewhere there. What?
2.
Alright, okay. I'll take point if we don't.
Are you guys ready for me to graph, or do we need a minute?
Well, I just it's like sideways. I don't know what a twisted tie is. Oh, twisted tie. You said tie. Yeah, I know that. I thought you said like tie. That's completely different.
It's the way to cut out. If anyone's got something like that, you can say they're setting the whole, like, the holes, like, snowing. No, it's related.
It's related.
It's the culture of our class. Oh, we're at like high over 4. We're not at the pool. We like high over 4.
I think the wall is 3.
Because we're not quite straight. No, like. Wait, Alex, you're a we're not actually. But we're so close to it. If you round up, it's flat. Yeah, but most people round.
All right, guys, that's what you should have gotten. How do we do? Yeah? Okay. Alright guys, let's look at the number 6 here. Okay. Anytime there's a 5, it's just going to be uglier because your petals are 72 degrees apart when it's 5. Yeah, it's not super convenient. So, couple things. Yes, you could plug in values between 0 and pi, and I'd plug in like 0, I'd plug in pi over 5, I'd plug in 2 pi over 5, 2 pi over 5, 4 pi over 5. Those aren't things that you really know on here though. So, something that's easier to think about. What did we talk about if this is odd and we're going from 0 to pi? What are you going to see?
It's done at 5.
Okay, let's look back. Where was the other one that we did?
It's pretty much done at 1. It only goes all the way up to 9. That's how it's getting that's how.
Oh, this one. Promise. Okay, so let's go look at this one again. This was 3 theta. If I had graphed it from 0 to pi, remember I saw all of it from 0 to pi, and then it just repeated after that.
Yeah. This one.
Okay? Not all of the odd ones.
Because it goes all the way to 5.
So,
While,
if
you know, even
numbers are low, but they're easier to plug values in for. Yeah. So, you can do this just like you were doing the ones last time in class if you want to. Find your first one, know that there's 5 of them, know that they're all 72 degrees apart. It's a -3, so instead of starting over here, where do you think it's actually going to start? Yeah. Okay. 1, 2, 3. So think about that, and then think about 72 degrees. Which 72 degrees is almost 5 of these tick marks, if you will. So like 1, 2, 3, 4, almost to there. That's 72 degrees. And so then you have to start from that and count almost 5 away, almost 5 away from that. You know what I mean? Yeah, when it's 5, it's just not as pretty. At the end, your petals should all look nicely spaced, though. If you mess it up and scrunch 2 together, I will notice. Okay?
I don't scrunch 2 together. Not to do that.
So what I mean by that is like, hey William, what I mean is like, let's say you draw it and you've got this,
Yeah.
and then this one's like right there, and then there's a big gap until you get over, you know what I mean? Like, that's what I'm talking about. So you can't just like throw them anywhere you want.
Yeah, I'm trying to do it.
So,
I do that at 7.
If it's 0 to pi, it's 0 to pi over 2. Like, because that's what I think our first ones were here. See how that was only 0 to pi over 2? That's why we saw half of it.
It's 9, I think it was 9.
I don't want to grade 7. You'll see a lot of 2, 3, 4, and 5 as your main values. You might have a 7 that's like a writing equation of this, or like a matching, but not. Probably not. No. I mean, what it would be is just plugging in. So like your R and your theta, you'd have to do 0. You'd have to do pi over 5, and then be like, okay, I know that's approximately 32 degrees or 36 degrees. It's not impossible. I just think this was easier. Yeah.
Now I'm in a mind. So how do you, what's a quick way to know what points you're going to want to use?
Like for this one, or
Yeah,
for
in general, like what's a quick way to recognize?
like you mean picking your thetas?
Yeah.
So I'm picking things that when I plug it in here are going to give me a 0, a pi over 2, a pi, a 3 pi over 2, usually. Something that's nice, because like, Yes, I could pick pi over 6 here and plug it in, and that would give me the sine of pi over 3. But that's root 3 over 2 times the, I don't want to do that. Okay. All right, so let's
You're not drawing it. Wait, what do you mean? It's on a continuous curve. How do you think I want to see this curve? Yeah, you're not doing it like don't judge myself. I'm not saying it's that. I'm saying it's not skinny. I know you do this all in one piece.
All right, guys. Are my petals perfect? No, but are they spaced pretty nicely?
Yeah.
Okay, that's what I'm looking for.
Yeah. So when the theta is on, you can see the dollars.
By the time you get to pi, okay? If it's 0 to pi over 2 and it's odd, you're only going to see half of it. Okay? 0 to pi when it's even, you only see half of it.
What's the name? We need to know how to do 0 pi with the odd.
Well, we did it with 3,
Oh, okay.
right? Didn't we do it there?
Yeah.
With a 5, it's probably going to be
Will all these be ready to start first point, or do we have to do the thing that we did before when we done?
Well, that is what you get when you do the things that we did before.
Well, won't it be like that easy, like you see -3, twist the -3.
Well, because it's cosine, it's that easy.
Oh, so it's a sign we have to.
It's what, I mean, you're thinking about. Yeah, I mean, you have to actually solve it if it's fine, but you know, I feel like you do enough of these, you start to be like, okay, I get it, like sine usually looks like this, if it's negative, it goes the opposite direction. It's okay to like, just think about it too. It doesn't always have to be, I must show these step by step, which I know you guys like when there's a step by step process. Sometimes it's just thinking. Just, okay. Not your strength. Oh, BC calculus, a lot of just thinking in there. So, a lot of, okay, what is this question want me to do?
Yes, I think there's a lot of thinking in this.
Yes.
What lessons is the first one?
It is graphing everything. So that could be anything we've done so far, but there's none of the like converting from rectangular to polar. Okay, that was your homework. So let's go back. Let's just practice a couple more of these. Let me give you an interval. I don't want to do another one of those. So let's do this one.
I probably need to do
I'm going to jump around a bit, guys. So we're going back now to number 3. This is in your packet. You see it? But I'm giving you an interval. That was not good, okay?
I mean, you're supposed to do what you're supposed to do, right? Yeah. You're supposed to do something. Yeah. Just so like if there's a question like the one we just did with the 5 theta, you want us to draw it. You don't mind if we like don't draw it here too, like if we try to draw the petals separately because it's kind of hard to draw.
I'm not going to be like watching you on your quiz. Okay.
Yeah.
That's not I won't know. Okay.
I feel like something you probably have known.
They'll just like look it up on microscope and see if you can pick up the pencil.
Can you bring in a handwriting specialist?
We can tell here that when he was drawn, he actually stopped. His pencil.
That's -1/4 points. Who's really spending a lot of time thinking about where you're going with this. That's good work.
only have to go to theta. I don't know what that is.
We're in the middle. Doesn't have
Look at the points that pi over 2.
Are we gonna be
It's only pi over 2, by the way.
1 times 3. 3. That's pi over 3. Pi over 2 times 3 is pi over 2.
Well, I mean, I don't really have a lofty origin. I don't know if that's good. I don't put a dot to the origin. Oh wait, it's not even called the origin, it's called the pole. You gotta get into the pole. We're doing different one.
Alright guys, what does your graph look like for this one? Did you do 0, pi over 6, pi over 3, pi over 2?
Oh, like it.
What do you get when you plug in 0?
Okay.
What about when you plug in pi over 6? Pi over 3? Pi over 2? Alright, so start here. And then you go 1, 2, 3, right? Back.
Also fun.
Enjoy the sound of that. There we go. Yes?
Yeah, I feel confident. I'm feeling more confident.
Okay.
Yes. I don't think you're
Alright.
You're gonna have to be more specific than that because
I want to change one of these. We're going to come back to 4.
Hey, when you guys are way wrong,
Alright, we'll do this one. I'm going to make it kind of weird. And I'm not saying you have to do this on your quiz. I'm just saying, let's try it. What if I give you a different part?
It's good to try this because you're gonna have to do it on the test.
I don't know. I'm the one rewriting your test, so
I still think there's I mean, this is probably on the test.
I haven't decided yet. So I'm changing stuff. I'm putting more of like the over specific interval. Before we just made you a graph a little bit.
Okay. So like you're adding stuff.
I don't know that I'm adding this. Debate.
You can add the specific problem.
I mean, you can just erase from 0 to pi. I went through like 30 erasers like this year. I probably went through like 20 pencils behind.
release the password quickly.
I'm like, you look very confused.
Almost predicted that.
I don't force it because it's too.
We're in like
That's not really high.
that was good. Clearly, you're gonna do you remember you just need to know in your head, like, oh, that was, one and a half. You have the shape of the kind. Sometimes if you just plop it off, you can change All right, guys, let's look at this one. A lot of you got it. Some of you seem a little stuck.
Yeah.
All right, so my thetas, I'm going to use pi. And definitely 3 pi over 2 and 2 pi, right? What do you think I want in between there, though? So, like 5 pi over 4 and 7 pi over 4? Yeah? Okay, does that make sense?
Yeah.
So my R values I should get are 4, 0, negative 4, 0, 4. With me there? Okay. So the first one, I go to 4 and then travel around pi. So that's over here. Then I'm at the pole. Okay, so I've gone there. Then negative 4, 3 pi over 2. That's actually way up here. And back to the pole. And then 4, 2 pi is out here. And you're done. Okay? This is especially where it's helpful to understand, like, I should only have 2 petals. I saw a few of you that connected this. That's more than 2 petals now, right? So you know something's not quite right. Yeah. Okay. We have less than 10 minutes left here before lunch. I can give you more of these to practice, or do you guys want to look through your notes at Lima Songs?
It's like the old.